Hello students, today's topic is modular programming. We are continuing the modular programming from last week. So in last class we had learned modular programming, advantages and disadvantages of modular programming, and we had written some modular programs also using sub procedure. And in that modular programming we had talked about argument and parameter. So we are going to discuss in detail about argument and parameter now. So parameters. Parameters are the variable that we use during declaration of the sub procedure or function procedure. That means in the declare statement, whatever we write inside bracket, that is called the parameter. They are also called the placeholder. That means they actually receive the value and do perform calculations in the definition. It can only be variable. That means constants cannot be used here. Argument are the values that are passed to the procedure or sent to the procedure during calling the procedure. They can be variable as well as constant. So let's see its difference. Parameter are the placeholder for the argument, whereas argument sends the value to the procedure. And parameter determines the type and number of argument, what types of data and how many data can be passed, that is determined by the parameter. And argument gives those value to the parameter. For example, in the statement declare sub sum x y, here this x and y are called parameter because this is in declare statement. So we need to remember that whatever variable we write inside bracket in the declare statement, that is called the parameter. And here in case of argument, this xy that we write in call statement inside bracket is called argument. So the another name for parameter is formal parameter, whereas arguments are called actual or real parameter. Okay, in previous programs, in previous examples, we had written same parameter and argument. That means same name is used for argument and parameter. Now we rarely do that in practical work, so we are learning to write different argument and parameter. Let's see. Here is a program to read radius and height of a cylinder to find its volume. So we write here declare sub volume because we are going to find volume output. According to the output, we are writing here the name vol, and according to the input, read radius and height, we are writing radius and height. Or for the calculation of the volume, we need these two as input. So in this way we had written here declare sub vol, the name as its output, r comma s as the input we had written here, and cls. So as we need r and s, we are taking input, enter radius and height of the cylinder. Now we are using different variable for radius rad, for height hei. So these two variables will have the value given by the user, so they are to be passed during calling the procedure. So here in call vol, we are sending this value of rad and hei. Whatever we send from here, that will be sent to the procedure. So just after calling the procedure, we had in this over here, main program is over here, and how does this procedure do its work, we need to write in the definition. Now in this definition, we are writing this sub vol rs, and this inside this sub in sub, we need to write the function and its output as well. So what function we need to do over here is v equals to, the formula is here, pi r square h. So using this R and S, the calculation is done here in V and the output is given here. Now here what actually is happen is this R comes here in R, so red come here in R, and HEI comes here in H. What we need to remember here is the variable used in input statement are to be supplied as argument. These two variable used here as input variable are sent as argument here during calling, not R and H. This is to be remembered because users value are there in RAD and HEI, so that is sent here. Whenever it is sent over here, during running the program controls from top to bottom. Program control flows from top to bottom and it reach over here. On reaching over here, it does not go to the end. It goes to its definition block. So from this call statement, it comes over here. That means program execution goes here. And here, RAD gives the value to R, HEI gives the value to H. Now these two will have the values that were entered by the user. So from here it goes over here and comes over here, and R has the value of radius and H has the value of height. The two are used here for calculation and the calculation is done and printed over here. That is why, however, we see here R and H, the work is done for the values of RAD and HEI. So it gives the value out here. And now some procedure may have empty bracket only. That means they may not have any parameter. This is the case when there is no input. In such cases, we write procedure without parameter. So let's see in an example. Here is a program. Write a program to display first 10 natural number. When it is said first 10 natural number, then user do not need to take any input. So when there is no input, it becomes like this: declare sub series and empty bracket, as there is no input. So as there is no input, we have no input statement over here and we directly call that procedure. Now during calling the procedure, as it is empty, there is no need to write brackets. So, and during writing its definition also, the brackets are not written, and the statements for the output is written here. As we need to print 10 natural number, this block prints 10 natural number. It is well known to us. So this is the program where there is no parameter. That means this is procedure without parameter. So what we need to remember here is, if there is no input, in such case we write the procedure without parameter or blank here. When it is blank, during calling also no parenthesis. During definition block start also there is no parenthesis. Okay, here are some exercise to practice. Here we read program is initial velocity, time taken and acceleration to find the distance covered. So if you go to qbasic, then declare sub, as its work we write the name because it's said to find the distance covered. So right here let's say this, and it needs the inputs are velocity, initial velocity, time taken and acceleration. Initial velocity u, time taken t, acceleration a. So using this we need to write the program. CLS input enter value, let's write in short, okay, value of u, t and a. better, as we are writing different argument and parameter. Let's write initial velocity, time, acceleration. Initial velocity, so I'm writing different variables. Now during calling, call this, we send this x, y and z respectively, and now solve this u comma t comma a. This is to be remembered because whatever we had written over here, we supply that. So now using this u, t and a, we need to write the formula. S equals to u t plus half a t square. So here we found the value, and it is to be printed. Print distance, distance covered is yes, and so now let's run this, creating exe. So compiling, let's say initial velocity 5 meter per second, time taken 1 hour, and acceleration let's say 5 meter per second square. Then it gives the distance covered 7.5. So in this way it does its work. Actually here this x is received by u, y is received by t, z is received by a. So it works in this way. And for the program with without argument, let's say this is the case of series of even numbers till 20. Yes, okay. Declare sub for series. I'm writing here ser only, and as there is no need of input, empty parenthesis, cls as no input, directly calling that, call ser, and this ser has no parenthesis, so no parameter, so no parenthesis over here. And during writing definition, sub ser and no parenthesis. Now for printing 2, 4, 6, 8 till 20, a very simple for loop can be used. For I equals to 2 to 20, step 2, and print I, next I, and sub. So let's see, does it work or not? Here we have got the output. So in this way the subprogram without parameter works.